take one class.
Good morning. Okay, now today we will talk about review for exam 3. As we know, exam 3 will be on this Friday, November 11. You need to show all of your work and make this and it should be also handwritten submission. So you don't need to submit this on Canvas. And it's scheduled from 8 to 8:50. We will please try to come at least 15 minutes earlier so you can have extra time, which is as usual, as the same as in the second and first exam. So we will try to start around 7:45 or 7:50 so you can have extra 10 minutes. The test is a closed book, closed notes. There is 2 side note sheet allowed. And the first exam was note card, the second exam was note sheet, one side, now 2 side. So it must be handwritten. You can write whatever you want, but it must be only 1 sheet. 2 sheets, 1 side is not allowed. It should be one sheet. Some people wrote their note sheet on iPad or something like that. So you can write it in the iPad, but print it. That's fine. Make sure it's handwritten. So don't use any electronic device, but you need to print if you already have your note sheet on the iPad or any other device. Okay, so again, no electronic devices are allowed. Don't forget your calculator. Make sure your calculator is compatible with complex numbers. Make sure or review how to use the complex numbers. It's very important in dealing with complex numbers. Look at the second exam. Look at your mistakes in the second exam. Make sure you will not do the same in the third exam. Make sure you will not waste a lot of time in doing the complex numbers analysis using the calculator. So please make sure, again, to know how to handle with these situations, how to manage your time when you read the question or when you take the exam. Look at the questions and start with the easiest one for you. If you are struggling with any question, keep it. Go to it later. Go back to this later. Don't struggle with the first question. Let's assume the first question was the most difficult one. Don't spend half an hour on that question. So try your best with the easiest question for you. If you find all of them are the same level, then start with the highest points. So you can, let's assume question number 2 has 30 points. Then start with the highest point questions. Okay, now the topics that will be covered in the tests from chapter 8. 3-phase AC circuits, power transformer, power system overview. So all of these are included in the tests. And also there is additional notes about the traditional AC generator, which is the 3-phase synchronous generator. Then from chapter 15, the 3-phase synchronous motor. We already talked about the similarities and the differences between 3-phase synchronous generator and motor. And also the 3-phase induction motor. We already talked about this last lecture. So basically we'll be from lecture 22 until 31. What you need to study, the first and the most important thing is the lecture notes in addition with the textbook as well. And then the quizzes, worksheets, the homework problems. I encourage you to do this after finish everything. So most likely I encourage the students when you do the homework problems, do them during the weekly routine, which is after class. I say like you can go to this supplemental problem or this homework problem and try them. You can try them during the classes, but not for studying the exam. If you are studying for the exam, make sure to finish all these 3 topics. After that, go to the homework problems. So what I expect from you, which is you already tried the homework problems, then you have your notes about maybe this problem, I need to focus on this problem, or the idea of this problem is this. Then you can go back to your notes that you already written about these problems. So the exam is consisting of 4 questions of the following topics. It can be any of the 4 of these things. It can be about the balanced 3-phase AC circuit analysis. Basically similar to the quizzes, you have Y to delta connection or Y to Y connection, and you have maybe a transmission line impedance in the middle. It can be series or parallel. Basically what you need to do whenever you see delta, convert it to Y. If everything is Y, then that's fine. You don't need to convert anything. After that, convert 3-phase to single phase. Then you have only single loop, or you can have maybe 2 loops if you have an impedance in parallel, so you can apply your analysis to find the currents or the voltages or anything that you need to find. It can be also power in 3-phase circuit analysis. So the given value in the question is the power in 3-phase. So whenever you convert 3-phase to single phase, make sure to divide the power by 3. And sometimes the apparent power is given, sometimes the real power is given, so you need to know how to calculate the complex power. Basically, you have a power factor, cosine inverse of the power factor, this is the angle, then you can find the complex power, easy. And it can be also power transformer. It can be included either 2 windings or 3 windings transformer. So we already talked about the power transformer. There were 4 examples on this, and it was one of the quizzes forms about the transformer. And there was also the homework problems also about the transformer. So I think those should be enough. Basically, you need to know the 3 equations: the voltage equation, the current equation, and the power equation. If you know all of this, how to apply this stuff, then everything should be fine, because we already know how to solve the AC circuit analysis from the 2nd exam. So the only thing new is how to apply these 3 equations.
Transistor.
Then 3-phase synchronous generator, which is the traditional generator. This is not in the textbook.
Code.
This is from the notes, additional notes. Then you can try them, or you can look at that question or that example, how to apply this, how to look at the worksheets. You need to know that there are 2 speeds for the synchronous. There are electrical speed, and there is the mechanical or the rotor or the synchronous speed. They are all the same. Rotor speed, synchronous speed, mechanical speed, they are all the same for the synchronous. While when we go for the induction, it's different. We have the electrical speed, mechanical speed or synchronous speed, and we have the rotor speed. So the rotor speed is different. So also you need to know the differences between the synchronous motor, or between the motor and the generator, by looking at the current direction, or you can swap EF or VA, as we talked about this so in the worksheets. Also, you need to look or know about the 3-phase induction motor. What's the differences between induction and synchronous, which is synchronous most likely at constant speed application. We are talking here about old science or conventional thing, which is for constant speed applications, while induction for variable speed. The synchronous, the type that we talked about during the class, including the magnets inside the rotor structure. While for the induction, there is no magnet, there is a coil. And that coil, there is a current flowing that coil, which causes the magnetic field to being produced. Then we have a magnetic field, electrical current to produce a moving part according to Faraday's law. So the class progress, which is from lecture 22 until 30, they are all summarized here. I summarized everything we covered since October 17 until November 9. So you can, I already uploaded this in the announcements on exam 3 information. You can expect to see this, and also these notes will be uploaded in Canvas. You should expect to see them today. Then everything here, everything will be covered in this class. You will see this in a PDF file. So here you can see the problems, textbook problems, the worksheets associated with this, the readings, which means the chapter number, I think this is the worksheets. Yeah, the readings. I don't know why they are not here, but it doesn't matter. So make sure look at the worksheets and the textbook problems. Here are the topics. Now let me go to talk about the quizzes. a little bit about the quiz. Quiz number 6 was about three-phase problem, like this. This is form A. Form B, the same, but I think with different numbers. When you have these kind of questions, the first thing in mind, don't apply the same as what we talked in the class. So the new thing here is we have a transmission line impedance. While in class, the example in class, there was no transmission line impedance. So here, the transmission line is in series. Sometimes maybe you can see this in parallel. You can see multiple. It doesn't matter. You should be able to handle it. So when you see this thing, we have y, we have delta. Before doing anything, convert delta to y. After that, the problem will be clearer. So after converting delta to y by mentioning delta zy equals z delta over 3, then you can start your analysis. So here, the first step, find all 6 voltages. We know how to do that. We have V line to line is given in the question as 15 kilovolts. Then V line to line divided by 3 to find the answer. Is it 15? Oh, I think this was the makeup answers. Okay, doesn't matter. It's the same idea. The makeup quiz answers. So this is different than this quiz. So V line to line, V line to neutral. Okay. To find the 6 voltages, V line to neutral equals to V line to line divided by square root of 3. Here there is no bar because we are talking about the magnitudes. After that, we will say VAN equal V line to neutral, angle 0. This is VAN. Now, is there any information about the sequence? No, then it's positive sequence. So VBN will be V line to neutral angle negative 120, VCN equal V line to neutral angle positive 120. Now, how to find the other 3 voltages, which are line to line, VAB, and we have VBC, VCA. You can do the general formula, which is VAN minus VBN, or you can say either VAN minus VBN and calculated it, or you can say that it is VAN times square root of 3 angle 30 degrees. And it is positive 30 degrees because it's positive sequence. The default is positive sequence. And so on for the others. This is the first unknown. The second unknown, find the line currents. The line currents are IA, IB, IC. How can we find them? Basically, as I said, convert delta to y. So ZY equals to Z delta divided by 3. Then converts, here is delta to y, then convert 3-phase to single phase. Then we will have only single circuits, which is VAN. Here is Z line, and here is ZY, or in other words, which is Z delta divided by 3. Then we need to find the current I. So I, since it's single loop, will be V over the sum of Z. So here VAN over sum of Z, which is ZY plus Z line, or Z delta over 3 plus Z line. And that's it. It took only 5 minutes to do that, so whenever you see these kind of problems, it shouldn't take too long. Okay, clear? Now for quiz number 7, I think quiz number 7, there were 2 forms. The first form associated with the 3-phase power, the second form with the transformer, power transformer. So here, 3-phase system, 500 kilovolts load, has a power factor 90 lagging, and supplying 480 volts source. Determine the 3-line currents. Whenever we see this, the first thing that will be in your mind, this value is it for 3-phase. The second thing, this is line to line. So we can say we have V line to line equal 480 volts. Therefore, V line to neutral equal V line to line divided by square root of 3, which is 480 divided by square root of 3. Then it's going to be 277.12 then VAN equals to V line to neutral angle 0, which is 277.12, angle 0 degrees. We have done this many times, and we are keep doing it. So I assume everyone should be able to do all of these analysis. Now, this is the first thing. The second thing associated with the power. We have 500 kilovolt ampere. Is this real, reactive, or apparent power? Apparent power. Why? Because it's volt ampere, so it is apparent power. Why it's not complex power? Because it's not associated with angle. That's why it's apparent power. So we have S, but we know S complex is S angle theta. How can we find theta? We have the power factor equals to 0.9, and it is lagging. Therefore, I'm sorry, this is the power factor. Theta equals to cosine inverse of power factor, which is 0.9. Then it's going to be 25.84. And is this positive or negative?
Positive.
Positive, because it's lagging. Therefore, substitute this here. Then S bar will be, what was the value? 500 times 10 power 3, angle 25.84 degrees volt ampere. So the question didn't ask me to find the complex power, so it's trying to keep it in polar. You can make it in rectangular, that's fine, but we need to save more time. We need to do how to do this in faster time, so you don't need to convert this to rectangular because the question didn't ask me to find the power. We need to find the currents. So we know S bar equal VAN times IL conjugates, or let me call it IA conjugates. So how can I find IA? Easy. Okay, before doing that, this is S3 phase. Okay, I missed this point. We need to calculate the single phase. This is S for single phase. So we need to say S single phase equals to S three phase divided by 3. Don't miss this point. So you need to divide it by 3. So 5 divided by 3 is going to be almost 1.667 times 10 power 3, angle 25.84 degrees volt ampere. So this is the value that we will use here.
Wasn't it 500 to the power 3?
500 is given here.
Yeah.
Yes.
How did you get 1.667?
Divide by 3. 5. Okay, 1.66 times 10 power 5. Yes. I'm sorry. Thank you. Times 10 power 5. Right. Okay. Now, we need to calculate the current. So IA conjugates will be a single phase divided by VAN. Now let's substitute the values, which is 1.667 times 10 power 5, angle 25.84 degrees, divided by VAN, which is 277.12, angle 0. Then the answer will be 601.4, angle 25.84 degrees. This is the I conjugate. Don't forget to do the conjugate for the answer. Then IA will be 601.4, angle negative 25.84 degrees ampere. This is IA. How about IB, IC? Apply the phase shifts. The sequence is not given, then the default is positive sequence. Therefore, IB and IC will be the same magnitude. So I'm going to write it as IA times 1 angle negative 120. Here is IA times 1 angle positive 120. So just add 120 to the angle, then here subtract 120 to get the answer. Okay? So don't forget to find the answer as well. Any questions? Now for part B. In the following circuits, we have VO, determine VS. Here in the quiz, I make it easier for you. So I assume the current direction and the voltage polarities. But in the exam, it will not be given. So you will see the circuit without IL, without I2, without V2, without V1, without I1. So what you need to do, you need to calculate, you need to assume the first step, assume the current directions and voltage polarities. How can I assume that? The positive side of the voltages at the dots. The positive side of the voltages at the dots. The current enters the dots. The current enters the dots. How about the load currents? Assume the load current enters the positive side of the voltage load. Then I2 and IL are the opposite direction. Then I2 equal to negative IL. Okay? Clear? Now you can start the analysis. The turns ratio here is given 1/2. Some people couldn't figure it out in the quiz. They just tried their own turns ratio. So here it's given. So look, sometimes read the question carefully, then you can find it. If you cannot find it, you ask. Don't assume. Don't assume it because it should be provided. So here is the question. I assume this one as ZTHV, this is ZTH, ZTL, ZL. So basically, we have VO, apply Ohm's law, we can find IL. After finding IL, I2 are the opposite side of IL. Then we know I2. Apply the current formula so we can find I1. Then I1 done. Then the second thing, we need to find the voltages. So we have here, we know VO, the voltage of this capacitor, we can find it, which is I times Z. But this voltage, we couldn't find it. Then we have only one unknown. So here is loop 2. Here is loop 1. Apply KVL into loop 2. We have V2 is unknown. Then we can find V2. After that, we can find V1 by applying the voltage formula. Then we have the currents. We have the impedances. We know V1. So by applying KVL, we will have only one unknown. So make sure when you apply KVL, you have only one unknown, which is here. If I apply the first step, KVL here, I don't know what's V1. So I need to know V1, which is yet basically using the voltage formula. When I go here, I want to apply KVL. I know VO. I need to make sure that I have I2 or IL. I need to make sure to calculate the currents. So basically, when you do the transformer, find the currents first for everything. After that, apply KVL. Apply KVL from the given information, go back to the source. Don't start from the source, from the available information. The given information are here. Then go back to the source. Start from the load back to the source. This is the best method, so you can save more time in thinking and just follow the procedure. You can write this actually in your note sheet, so you don't need to memorize anything. So you have the tool or you have the manual and your rule as engineer to solve this problem. So you have open source or almost open source, which is you have the manual or the data sheets, so you should be able how to handle it.
Was V not given in this problem?
Which one? V?
All right, V.
VO? VO is given here. 4 angle 30. Okay, so most likely the average of the third exam will be in 80s out of 100 because it's straightforward. Just follow the procedure. You already have the information in your note sheets. So your job is how to make sure if you are understanding the topic very well, not memorizing the formulas, how to apply the formulas, how to, like as an engineer, how to apply, how to solve the problem by the available sources. You have the manual, and you have a problem, technical problem, or something like that. So your role as troubleshooter or solve this problem. Then maybe the topics look like maybe a lot or complicated, but it's gonna be all right. Worksheet number 12. You need to make sure that the simple n associated with RPM, while the simple omega associated with radian per second. Okay, because it's the same speed. There is nothing related to it, but it's again associated with when we talk about the distance in feet, inches. It's the same. And also, how to quick the conversion between radian per second to RPM. You need to write this in your note sheet because you will need it. If you have the available information in RPM, sometimes in calculating the torque, load torque, you need to have the currents in, have the speed in radian per second, so you need to know how to make the conversion. And electrical speed associated with the frequency, so RPM, which is F times 60, omega equal 2 pi times F. This is for electrical. For mechanical, just add 2 over number of poles, and keep in mind the poles must be even integer. Okay? And the only case electrical speed and mechanical speed are the same when the number of poles equal to 2. Then we worksheet number 13, the differences between the motors and the generator. So the generator, most likely EF, this is the type, this is the generator. So the current going out of the generator. While for the motor, the current going in. Or you can swap these two by making here is VA, here is JXD, here is EF. So this is the motor, and here is the current. So the current is the same direction, but swap EF and VA. So you need, that's what I recommend, because most likely the textbooks or the other references are using this approach, not reversing the current. They are using this approach by swapping VF and EA. So when you see any problems associated with synchronous motor or synchronous generator or induction motor, the first part of the question will be draw the equivalent circuits. So this 5 points for drawing the equivalent circuits, I assume you already have this circuit in your note sheets. So make sure to draw this in your note sheets. Draw the equivalent circuit of the synchronous motor, synchronous generator, and induction motor as well. So again, there are 5 points associated with drawing the circuit. Even if you write nothing, just draw the equivalent circuit, you will get 5 points. So you need to be clever how to earn more points. Okay? How to find the efficiency for the synchronous motor. P out over Pn, P out equal 3 VO, VA and IA cosine, alpha AN minus beta A. Keep in mind they are all real numbers. Don't substitute complex numbers here. The real power, there is no way to get complex number real power. It's real power. How can I get complex power? So make sure, don't substitute the angle. If you get complex numbers, this means you are substituting the complex number here. This is the magnitude, this is the magnitude. There are no bars, then only magnitudes. Then you need to calculate P in and P out. Most likely the load torque will be given, and omega S you can calculate it. The frequency is 60 hertz. If it's not given, it will be 60 hertz. So you can find omega by 2 pi times F, then convert this to mechanical, which is times 2 over number of poles to find omega. 2 pi times F, then 2 over number of poles. Then load torque most likely is given, then you can substitute this to find P outs. Pn, you need to calculate the currents, and you have the voltages, then you can find the current, then you can find the efficiency. And there is a formula associated with development torque in case if you need to find delta. Sometimes EF is given, VAN is given, XC is given, but delta is not given, is not provided. How can I do that? How can I find delta? Basically, you have the load torque, you have the rotational losses torque. You need to calculate them first to find the T-diff, or the development torque. After that, find P developments by making T development times omega. Then you already calculated P-diff. EF magnitude is given, VAN is, you can calculate it, which is V line to line over square root of 3. XD is given, then you can find sine delta. It's the same as example that we took in the class. Then we can find delta. In the generator, delta must be positive and the motor must be negative. So keep in mind, if the question is synchronous motor, after finding delta, put a negative sign. How about the differences between synchronous and induction? Here, for worksheet number 14, just you need to know that for the generator or for the synchronous motor or synchronous generator, it can work for constant speed, and the grid is 60 hertz. This means constant speed as well. Then the best situation or the best solution that's suitable, the best generator that's suitable for the grid, use constant speed generator, which is basically the synchronous generator. While for the motors, when you have constant speed application, use synchronous. Variable speed, use induction. Again, this is in the old sense, conventional. This is right now no longer valid. We can overcome over these difficulties, but sometimes if we have large scale motors, this will cost us a lot. So we will still use the induction. We will still use the other stuff. But for small scale, for example, like electrical vehicles or some electric equipment, we can use the synchronous. That's right. Now the worksheet number 15 for induction motor, we have the synchronous speed, rotors, or we have electrical speed, synchronous speed, and rotor speed. The rotor speed now is different, is no longer equal to the synchronous speed, so we can find the ratio between the synchronous and the rotor, which is by using slip, which is omega s minus omega r over omega s. So basically, sometimes there are some methods in controlling the induction motor, controlling the speed by using called slip control. So slip control, you are controlling the slip, then I'm controlling the rotor speed, so I'm controlling the speed of the induction. There are many ways to control the speed of the induction, but this is one of the easiest way or more convenient way that can be understandable. The equivalent circuit for the induction motor, you need to write this in your note sheet. You need to, because there will be, if the question about the synchronous, the first part, draw the equivalent circuit, so you need to copy this from your note sheet. Most likely, in the exam, if there is a question about the induction, we will assume this is very large. Then we can neglect this. Neglecting this is very important because solving the circuits when we have this inductor in the middle, this means will cost you a lot of computational time. You need to calculate two unknowns, sometimes omega KVL, several KVLs, KCLs with complex numbers. This will take very long time. So you can spend actually maybe 50 minutes, the whole exam, on this question because sometimes dealing with complex numbers. So I want to make the question easier so you can spend less time by basically removing this so you have only single loop. So you can find the currents is easy, which is VAN over the sum of all of these. Then it will be easier instead of doing 2 KVL and 1 KCL. So this will take a lot of time, a lot of effort, and the chance of getting calculator error will be a lot, especially with the lack of experience of complex numbers. So we want to make sure that you can solve it in an easier way and with less computation time. So IA will be VAN over the sum of these. Keep in mind, you need to calculate the slip because this one is associated with the slip. And also by looking at this model, we have resistors. So in the synchronous, we didn't talk about electrical losses. We talked only about the mechanical losses, which are the rotational losses. But here we have two types of losses. We have electrical losses, mechanical losses. Mechanical losses are associated with the rotor losses. Associated with the rotational losses, while the electrical losses are associated with the existence of the resistors. So we have resistors in stator side, that's why we have stator winding losses, and we have resistors in rotor side, that's why it's called rotor winding losses. So you need to know the physical meaning behind all of this stuff. So it's not say SWL is 3 times I squared times R. This doesn't make sense for me. Even if you get a full credit for this question, but you are not understanding the topic, this does not make sense. Just apply the formula. So you need to make sure, understand the concept behind that. So when I talk about stator winding losses, what does stator winding losses mean? Why they exist? By looking at this model, Do we have a resistor? Whenever there is a resistor in the model, any modeling, anything, which means there is losses. And this losses goes as heat. And this heat is something undesired. That's why sometimes when you touch the motors, after being turned off, of course, you will feel they are warm or they are so hot because there is a losses inside the motor and goes as heat. And there is also rotor losses as well. And there is rotational losses, which is friction losses, as you know. So you need to know how to know all of these losses. So the efficiency will be the input power or the output power over the input power. Or in other words, the inputs or the output power is actually the input minus the losses. So understanding this fact, you don't need actually to memorize any formula, or actually you don't need to write them if you understand this, which is basically the output is the input minus the losses. So how to calculate V line to neutral, or VAN, which is V line over square root of 3, then angle 0 to find VAN, then stator winding losses 3I squared times R, rotor winding 3I squared times R. How to calculate I again, it's single loop, so it will be V over the sum of these impedances, and then don't forget to divide by S here. After finding the current, then 3I squared times R, 3I squared times R. Keep in mind, for the rotor, we are using the whole R2, not R2 over S. So just follow the formula. Then the sum of losses, which is the electrical plus mechanical, or the stator winding losses plus rotor plus rotational losses. Most likely, the rotational losses are given as torque. So you need to calculate the torque first, then find torque power characteristic using P equal T times omega. Then you can find the power. The net thing, which is P out, or efficiency will be P out over Pn, or P out over P out plus losses, or Pn minus losses over Pn. It doesn't matter, you can use any of these three formulas. So if you calculate the losses, you can use any of these. If you didn't calculate the losses, you can use Pn, P out directly without the need to use everything. And Pdev is actually 3I squared 1 minus S over SR2. Also, you need to write this in your note sheet. P out equal Pdev minus P rotational losses. P, there's torque power characteristic, how to make the analysis. And don't forget that Tdev, which is torque rotational losses plus load torque. Load torque are given. Sometimes it's not. It depends. But rotational losses are given. Most of the time are given. Sometimes not necessarily to have the load torque. So you need to sometimes to calculate it based on the operating condition. So it's just basically read the question and follow it. So here is the input power. Here is the structure of the motor. The first structure of the motor, the current enters the stator, then goes to the rotor, then starts rotating and going out. So going out as mechanical energy. So when the current enters or the power enters the stator, there is a stator winding losses. Then goes to the rotor winding losses. Then starts rotating. There is a friction loss or rotational losses or mechanical losses. Then it will go as output power. Okay, clear? Any questions? Now let's go to quiz number 8. Quiz number 8. When you notice this, there was only word form A. It was only one form when I gave you that quiz, because when I make that quiz, I created 3 versions, form A, form B, form C. Form A was associated with synchronous generator, form B associated with synchronous motor, form C associated with induction motor. But when we had that quiz, we only covered the induction generator, the synchronous generator, and we covered part of the synchronous motor. So I didn't include the synchronous motor or the induction motor, because I want to make sure that we need to focus onto that topic, because we haven't covered the rest. So here I'm going to give you or tell you about the other forms, form A, B, and C. So you can expect or have extra examples associated with the induction motor and synchronous motor as well. So this is form A associated with generator. When we read this question, 20 megavolt ampere, 13.8 kilovolt, 60 hertz. So 13.8 kilovolt, this is line-to-line voltage. 60 hertz, this is the frequency. 20 megavolts, don't use it. This is the rated, don't use it. Use the operating condition. So here it says it operates at 6 1000 kilowatts, use this because it operates at rated voltage with 300 and generates 600 kilowatts with 0.8 lagging power factor. So the first part, draw the equivalent circuit, 5 points, draw the equivalent circuit. The second thing, determine EF source when operating at these conditions. How can we find EF? The first thing, to make it easier, that's why I draw the equivalent circuit, because drawing the equivalent circuit will make the problem easier. So the first thing, draw the equivalent circuit. I use a MathCAD software to do this. So most likely you will not see bars above the complex quantities because this is the nature of the software. But you need to keep in mind, put bars above the complex quantities. So V line to line equal, here is the equivalent circuit first. It's generator, so that's current going out of the generator. Then V line to line, we have convert to line to neutral, then find VAN. After that, we have the operated condition, the power of the three-phase. Don't forget, it's three-phase. So you need to divide it by 3. So here is the power of three-phase, 6,000 watts, kilowatts, which is 6 megawatts. And we have the power factor. So you need to calculate first the angle, which is cosine inverse of the power factor. A cosine means cosine inverse in this software. Then find the angle. After that, we can find the magnitude of the apparent power. We know that S equal P times power factor. So we can find the magnitude or the apparent power by dividing three-phase power divided by real power factor. So we can find the magnitude, then find the complex power, which is 7.5 angle 36 megavolt ampere. After that, divided by 3, the three-phase, because we need to find a single-phase power. Then we will say here the power here associated with the motor at the motor terminals. So here is the motor terminals at point A and N, not at EF. So at point A and we know the voltage, we can find the currents. So S equal V times IA conjugate. So IA conjugate will be S over Vn. Then don't forget to multiply the conjugate. Here in this software, bar means conjugate. I don't know why but that's what they use. So here this bar means conjugate number. So the conjugate means negative sign. Then we calculate the currents. After that, we know the currents. Let's go back to the circuits. We know the currents. We know VA. We know XD. The only unknown is EF. Apply KVL. So which is minus EF plus IA JXD plus VAN. Then we can find EF easily. Clear? Okay. Now let's go to Form B. Form B, this is associated with the motor, synchronous motor, three-phase. So we have 480 volts, 4-pole, 150 horsepower. Don't use this value, 150. And 480 volts, this is line to line. So how to calculate this volt operation? What do we need to find? Determine EF bar necessary for the operating condition. We need to find EF bar. Here we have load torque. We have EF. We already have it. But the question asks us to find EF. What does this mean? We know EF bar equal to EF angle delta. So we already know EF, which is 380, but we don't know delta. So how to calculate delta?
That PDEV formula.
Yes. So before starting this, let's analyze the information that we have. We have the absolute value 380. We have XD 1.25. Is it here 1.25? Yes. We have V line to neutral. Then we can find V line to line. We can find VAN. We have number of poles is 4. Frequency is 60 hertz. The best thing is to use PDEV. PDEV equal 3EF VAN over XD. Sine delta. Delta is unknown. EF is given. VAN, we just found it here, 277. XD is given. 3 is given, but we don't know PDEV. Then the best way to find PDEV is to find first the speed. So to calculate the speed, we have number of poles, we have the frequency. So omega electrical 2 pi f, omega mechanical omega e over 2 number of poles. Then we can calculate the rotational losses torque, the load torque. Then T dev equal T load plus T rotational losses. then the development power equal to torque development times omega. After finding the P development, then you can find delta. Keep in mind it's motor, then delta must be negative. Here, after making the calculation, we find delta is 15.95. But this must be negative. You need to put the negative sign because it's motor. Then EF will be 380, angle negative 15.95. And if you see a question like draw the equivalent circuit, then you should be able how to draw. Okay? Part C. A given load, 460 volts, 6 pole, 60 hertz, 75, three-phase induction. Now it's induction. So make sure read the question carefully. It's motor, induction, generator or motor or synchronous. Most likely for the motors, the power will be given here and the rated power will be in horsepower, while for the generators it will be in volt ampere or watts. So how can we find this analysis? What's the question strikes us to find the mechanical power, P outs, of the induction motor. And the operated condition is given 1,150 RPM. This is, we call it the rotor or the actual speed. And it's in RPM, that's why I call it NR. Now, how to calculate the synchronous? The synchronous speed based on the worksheets, 120 F over number of poles. Or you can calculate first the electrical, then convert the electrical to mechanical or to the synchronous. Then after calculating this, I can find the slip. So let's draw the circuits. The first part, you need to draw the circuit. This is the equivalent circuits. XM, we'll assume is very large, then we will make it like this. After that, we already have rotation or the speed, rotor speed. We have number of poles, then we can calculate the speed, what's called the synchronous speed, 120 F over number of poles. Here, sometimes in the analysis, sometimes I need to calculate the rotor speed in radian per second because the torque equation, here, there is a torque equation, 0.15 omega r times omega r. So this is, don't use 1,115 because this is n. You need to convert n to omega, which is basically converts RPM to radian per second. Go to the worksheets and you will see this formula. I should expect you to have this written in your note sheets. So it's 2 pi over 60 times NR. Then we can calculate radian per second. Then the information we have V line to line, find V line to neutral to find VAN. Then we can calculate omega electrical for in radian per second, 2 pi times F. Then omega synchronous, omega electrical 2 over number of poles. Then we can calculate the slip as omega S minus omega R over omega S. Someone can say, I don't want it to calculate this way. I want to calculate it as NS minus NR over NS. That's correct. They all should give the same answer. But keep in mind, you need to be consistent. If NS in RPM, make sure NR in RPM. Don't make this in RPM, this one radian per second. You need to be consistent with units. So we already have S. Let's go back to the circuits. Here is the circuits. We know R2, we know JX2, we know JX1, we know RA, we know VN. We calculated S, so the only unknown is IA. So apply KVL to find IA, or basically you can say IA is VAN over the sum of these resistors, of these impedances, which is VAN over the sum of these impedances. Yes?
Yeah. So I noticed that a lot of these omega and the RPMs and the radians per seconds equations like transfer over from generator to synchronous motor to induction motor. Does P develop do the same and does P out do the same and T develop do the same? Like, can we use T develop for synchronous generator, synchronous motor, synchronous?
The equation for P dev for synchronous is the same, but for synchronous and induction they are different. P dev of induction is different than P dev of synchronous, but the sum it should be fine. So
the same for
the same equation P dev for the synchronous generator is the same P dev as synchronous motor.
Okay.
Okay. Now, after calculating I, we can say P dev equal 3 times IA square R2 1 minus S over S. Then we can find P dev. P out equal P dev minus P rotational losses. P rotational losses, you need to calculate torque rotational losses first, then convert P to P torque to power. After finding that, we can find P out. If this question asks us to find the efficiency, it's going to be P out over Pn. How to calculate P out? We already calculated it. Pn, you can calculate it as 3 times VA and IA cosine alpha A minus beta. Alpha A and minus beta A. Then, problem done. That's how you calculate the efficiency. Okay, any questions? Okay, please, if you have any questions, feel free to ask me by email. Come to my office hours. The deadline for asking questions tomorrow at 5 p.m. After that, I will know. Thank you.